Hey everybody, this is Miss Darny. So, in this video, what I want to do is talk you through some examples where you have Lewis structures with single bonds and Lewis structures with double bonds, and you can't tell the difference until you start into the Lewis structure. The biggest thing to know is that you cannot tell the difference between something with a double bond and something that is just a single bond. Like, for example, SiO2 is going to be different than OBr2. They have both two outer atoms, but the Lewis structure of each of these looks vastly different. And here is where the math gets really important. You cannot tell whether or not you double bond by given the formula. You absolutely have to do the math. And if you don't do the math, you'll get the Lewis structure wrong every single time. So I don't check your math. I don't grade your math, but it is required to do Lewis structures correctly. So, let's get started with three examples. The first example is SiO2. So, we're going to have your element, number of atoms, valence electrons, and your total. We have Si and O. We have one atom of Si, two atoms of oxygen. So Si has 4 valence electrons, O has 6 valence electrons. Multiply across. 1 times 4 is 4, and 2 times 6 is 12. We get a total of 16. So we have Si in the center, and it's going to be surrounded by 2 O's. And so we've got 2 4 electrons involved in the bonds. So we have 12 electrons left over. We fill the octets of the outer atoms. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And we've used up all 12 electrons. Now, we can't put dots on the central atom because we don't have electrons to work with. We hit 0 already, so we have to double bond. So the way we double bond again is we take and erase a pair of dots from the outer atom, and we form a double bond in between the outer atom and the central atom. So that gives silicon 1, 2, 3 bonds, which is a total of 6 electrons. We have to do that again with the other oxygen. Erase a pair of dots and put a double bond in between those 2 atoms. And so silicon has now 4 bonds, 4 electrons in each double bond, so we have 8 valence electrons for silicon. And then the oxygens have, 4 bonds, 4 electrons in the double bond, and 2 pairs of dots, so that makes 8 valence electrons around the silicon. Okay, a different example. Now, I know a thing or two about Lewis structures. This is not going to double bond. Don't get into the habit of saying, oh, I have 2 outer atoms, I absolutely have to double bond. That is not true all the time. Okay? You have to do the math in order to figure that out. So we've got OBR2. We're going to start it off the same way. Element, number of atoms, valence electrons, and your total. We have O and Br. We have 1 oxygen, 2 Brs. Oxygen's valence electrons is 6, Brs is 7. 1 times 6 is 6. 2 times 7 is 14. For a total of 20. So we've got oxygen surrounded by 2 Brs. And so we've used 4 electrons in our bonds. So that gives me 16 electrons left over. Fill the octets of the outer atoms. And we have used up 12 electrons. So we have 4 electrons left over. Now, the leftover electrons goes on the central atom. So we have 4 electrons. We are going to always pair those electrons. So we have 1, 2, 3, and 4 valence electrons around the oxygen. And we use up all 4. Oops. And we hit 0. And then now just double check to see if everything has 8 valence electrons. The outer Brs has 6 dots plus the bond makes 8. The oxygen has 4 dots plus the 2 in each bond makes 8 valence electrons around the oxygen. And then the last example I want to do is CO3 minus 2, another ion. So here I want to do this ion. So element, number of atoms, valence electrons, and your total. We have carbon and oxygen. Carbon has one atom, oxygen has 3 valence electrons, carbon has 4 valence electrons, oxygen has 6. 1 times 4 is 4, 3 times 6 is 18. Gives us a total of 22. Now we have to account for this -2 charge. And again, that -2 charge means that we have gained 2 electrons. So we are going to add 2. So we get 24 electrons, valence electrons. So we've got carbon surrounded by 3 oxygens. And now I drew my bonds. So 3 bonds makes 2, 4, 6 electrons that we've used. So we get 18 left over. We fill the octets of the outer atoms. So 6 valence electrons around each outer atom. And that makes 18 valence electrons, and we hit 0. Now we need to check to see if all of the atoms have 8 valence electrons. The oxygens have 6 dots plus the bond makes 8. So that is good. But the carbon only has 2 electrons in each bond, so we have 6 valence electrons around the carbon. We need to get carbon to have 8 valence electrons, so we have to double bond. And the double bond, we are going to erase a pair of electrons. It doesn't matter which oxygen you pull from. So I'm going to pull from the one on the left. So I'm going to erase a pair of electrons and then draw another bond in between. Let's do one more. And let's do NBr3. Now again, just like the CO3 - 2, we have 3 outer atoms, but this is going to look vastly different than the CO3 - 2. So we have element, number of atoms, valence electrons, and your total. So we have N and Br. We have 1 nitrogen, 3 Brs. Valence electrons on nitrogen is 5, Br is 7. 1 times 5 is 5, 3 times 7 is 21. So we have a total of 26 electrons. So N surrounded by 3 Brs. Subtract our 6 electrons involved total in the bonds. So we have 20 electrons left over. Fill the octets of the outer atoms. And we have used 18 electrons, so we have 2 left over. Those left over go on the central atom. So you see how these Lewis structures are different. We started with SiO2, which we double bonded on each side of the Si. Well, a similar one is OBr2 because it has 2 outer atoms, but the Lewis structures are vastly different because you have 2 pairs of dots on the central atom on OBr2. So SiO2 is different than OBr2. And then the same thing with the CO3 minus 2. CO3 minus 2 formed a double bond because we hit 0. And then the NBr3, 3 outer atoms again, but we had electrons left over, so we put a pair of electrons on the central atom. So those are the mixed review of Lewis structures. Thank you very much for learning with me today. I enjoyed learning with you.